Hi, I'm Matt Bogenreif, flight instructor at the University of North Dakota Aerospace. On today's AeroCast, we'll be discussing precision approach procedures with a strict emphasis on the instrument landing system. As you can see, the weather's not too good out today, but it's a perfect day for instrument approaches.
A precision approach procedure is an instrument approach that utilizes navigational aids that provide not only lateral guidance, but vertical guidance as well. The most typical precision approach in the IFR structure is the ILS, or Instrument Landing System type approach. The Instrument Landing System is a ground-based airport navigational aid that provides highly sensitive lateral and vertical course guidance with range information provided by marker beacons and visual guidance provided by specific approach lighting configurations. Other types of precision approaches do exist, such as MLS, or Microwave Landing Systems, TLS, or Transponder Landing Systems, and the newly developed GLS, or GNSS Landing System that will utilize GPS satellites in conjunction with ground-based wide area augmentation stations to provide the pilot with GPS-based precision approach capabilities. Precision approach radar is also available at a limited number of airports in the U.S. that allows the pilot to conduct ATC-directed precision approaches. For the purposes of this lesson, we will discuss the specific execution of ILS approaches with standardization emphasis on UND Aerospace's fully digital Piper Warrior and twin-engine Piper Seminole. As in any instrument approach procedure, the execution can best be described by dissecting the approach into different approach segments. The first, the arrival segment, is the portion of the approach that takes the pilot from the en route structure to the initial approach fix. This segment could be defined by a Victor airway, a feeder route, or even by ATC-directed routing such as radar vectors. The pilot must use the arrival segment as his or her best opportunity to prepare the aircraft and the cockpit for the imminent approach. Prior to the initial approach fix, or the aircraft's last vector to final, the pilot must slow to the aircraft's approach speed, in this case 100 knots in the Piper Warrior and 110 knots in the Piper Seminole. The pilot must also complete a thorough descent checklist. The first item on the descent checklist requires that the avionics be properly configured. In the Warrior's digital cockpit, proper and organized avionics setup is a necessity. The pilot will first want to tune and identify the appropriate localizer frequency using the GPS-1 frequency selector knob and by pushing the NAV-1 volume knob in to properly identify the frequency. Finish by verifying that the final approach course has been selected on the HSI and that NAV-1 is in VLOC mode and not GPS mode. Since there's still a standby GPS 2, it is a good idea to use that GPS as a DME source for the nav aid in which DME is based for that specific approach. This way, the pilot will be able to maintain better situational awareness, and the DME may also aid in identifying strategic points along the approach, such as the missed approach point. The final item on the descent checklist is the approach briefing. Whether the pilot is acting in a single pilot capacity or the member of a crew, a thorough and accurate approach briefing must be conducted prior to any instrument approach procedure.
Today we'll be discussing the ILS approach runway 30 center at Williams Gateway. The first section we'll look at is what's called the arrival segment of the approach, which utilizes feeder fixes. For this approach we have three separate arrival segments. The first one will be noted by the Phoenix VOR, flying inbound on the 108-degree radial, which is approximately 22.5 nautical miles to the Snow intersection. The altitude to be flown for this segment of the approach is 5,000 feet when on this published second and cleared for the approach. The second arrival segment we can talk about is from the Stanfield VOR, transitioning on the 025-degree radial from the Stanfield VOR at 5,000 feet will take us directly to the Snow intersection, which is 27.1 nautical miles from the Stanfield VOR. And the final arrival segment that we'll talk about is from the Willie VOR. Transitioning on the 122-degree radial from that station, we'll transition at 5,000 feet to Snow intersection, which is an initial approach fix of the approach.
Once the descent checklist has been accomplished, the aircraft is prepared for the initial approach segment. This segment is defined by the portion of the approach that is between the initial approach fix and the intermediate approach fix.
The ILS approach at Williams Gateway has several initial approach segments. One of these segments involves arriving at the initial approach fix of the Tucson VOR and transitioning outbound on the 336-degree radial from the station. This segment ends at the 083-degree radial from the Stanfield VOR, which is indicated by Dalkey intersection. The altitude to be flown for this part of the course is 9,000 feet, and the lake distance is 44.9 nautical miles. When using this transition, no procedure turn is required or expected. Another option for the initial segment of this approach will begin at the Snow radar fix. The procedure for using this option is proceed outbound from Snow on the front course of the localizer, keeping in mind at this point that we will be receiving reverse sensing. Another important item to note is that this procedure turn must be completed within 10 nautical miles of the Snow intersection in order to be able to be considered to still be on a published portion of the approach. When cleared for the approach and on the published segment of this approach, the pilot may descend from the previous assigned altitude to 4,600 unless an altitude restriction has been placed. The third and final initial approach fix for the approach is Dalkey intersection. This procedure requires the pilot to arrive at the fix, then turn inbound on the final localizer approach course. No procedure turn is authorized, expected, or required for this segment.
The next segment of a precision approach is the intermediate segment. This segment is defined by the intermediate fix extending to the final approach fix. On a precision approach, this segment typically lasts from the start of the procedure turn until interception of the glide slope. If receiving ATC radar vectors, the intermediate segment can be described as the point from where the final approach course is intercepted until interception of the final approach fix. On this segment, the pilot will want to verify that the aircraft is properly configured for landing and that the before landing checklist has been completed. In the Warrior, the pilot will verify boost pump on, carb heat is applicable, gas to the fullest tank, and mixture rich. In the Seminole, the pilot will also have to bring the gear down and stand by on propeller control. This segment also marks the typical transition in ATC communication, as the pilot should be passed from approach to tower control or from approach to the Common Traffic Advisory Frequency, or CTAF.
In the case of our approach using Snow as the initial approach fix, this segment will begin when the final approach course is intercepted inbound following the course reversal. If we are to use the Tucson transition, the intermediate segment would begin once we cross Dalkey intersection until we reach Snow inbound.
The final approach segment begins at interception of the glide slope and not at the final approach fix prescribed by the approach plate. At this point, the pilot must complete a final configuration checklist. This checklist can best be remembered by using the tuple checklist. As the glide slope is intercepted, execute this checklist by starting timing, verifying that the undercarriage is down, reduce power to begin descent, and pitch forward to maintain approach airspeed. Finally, verify that the approach and runway lights have been turned on and set to the proper intensity for the airport of intended landing. After the final approach fix, it is the pilot's responsibility to maintain a stabilized approach by first making small, possibly half-standard rate corrections to maintain the localizer needle until a final freeze heading can be determined. Remember, the glide slope is extremely sensitive, and so the pilot should attempt to maintain a descent rate rather than attempt to chase the glide slope needle. Here's a good rule of thumb. By multiplying ground speed by 5, the pilot should be able to come up with a quick approximate descent rate that would facilitate a 3-degree glide slope. If the GPS were reading 100 knots of ground speed, then the approximate descent rate to maintain glide slope would be about 500 feet per minute. Use this number as a target value and then make small corrections for glide slope deviations. Once established on the ILS needles, the aircraft should be controlled by making power adjustments to maintain descent rate and pitch and trim adjustments to maintain airspeed. Remember, while on an ILS, as the aircraft nears the localizer and glide slope facilities, the needles in the aircraft will get more and more sensitive, and so the pilot should be ready to make smaller and more precise control applications as the approach progresses. Also, as a reminder, during any descent under IFR, the pilot should also make altitude callouts at least 1,000, 500, and 100 feet from target altitude.
The final segment of the approach will begin at the final approach point. This point is defined as the point at which the intermediate segment intercepts with the glide slope. The altitude at which this will occur is at 3,000 feet, as denoted on the approach chart. At this point, the pilot should begin to track the glide slope down to the runway, once provided that they are established on the localizer. The final approach fix is identified on the approach with the arrival at Snow intersection, which is at approximate altitude with the glide slope at 2,831 feet. Upon arrival at the final approach fix, the pilot should begin timing the approach in case the glide slope fails. Timing is the only way to identify the missed approach point if we lose DME and glide slope. This will allow the pilot to continue on the approach using only the localizer. The pilot should continue tracking the glide slope down towards the runway until they encounter what is known as our decision height. Decision height is an altitude indicated on the altimeter while on glide slope at which the pilot must decide whether to continue the approach for landing or initiate the missed approach. 3 conditions must be met in order for the pilot to continue below the decision height and descend to land. The airplane must be in a continuous position to land. What this means is that there's no excessive descent rate, the aircraft doesn't require excessive maneuvering, and it is in a stabilized approach. The second is a prescribed visibility located on the minimum section of the approach chart. That must be satisfied. The final one is a runway environment must be in sight. This could include runway threshold markings, touchdown zone markings, runway lights, etc. If only the approach lighting are in view, the pilot may continue down to 100 feet above touchdown zone elevation.
The final segment of the precision approach is the missed approach segment. This segment lasts from the missed approach point until the aircraft reaches the published holding fix where further coordination with ATC can be accomplished. When executing the missed approach procedure, the pilot must apply a prompt application of full power and pitch up attitude to establish climb speed. Similar to a normal go-around, the pilot must also retract gear and flaps as necessary and verify that full climb power has been established. Also, as a required report under IFR, the pilot must advise ATC that he or she is executing the missed approach procedure so that further instructions can be given and so that tower controllers can begin coordinating with approach or center. If at a non-tower controlled airport, the pilot may announce the missed approach to the CTAF and proceed with contacting the proper controlling agency for that airport for further instruction. Finish the missed approach segment by holding as published, following ATC instructions, and finishing all appropriate checklists.
The missed approach segment of this approach begins when the pilot decides to initiate the missed approach and arrives at the missed approach point. The segment will end when the pilot arrives at the missed approach fix. The execution of this missed approach procedure requires the pilot to climb straight ahead at 2,800. Upon reaching 2,800, the pilot can initiate a climbing right turn to 5,000 feet, preceded by a direct flight to the Willie VOR. Upon reaching the Willie VOR, the pilot should enter the holding fix, holding south on the 180-degree radial, right turns 1-minute legs as published on the approach chart. The pilot should note that this procedure requires a climbing right turn after arriving at 2,800 up to 5,000 feet. Should the pilot decide to initiate this turn prior to reaching the missed approach point, this could cause some serious situations involving other aircraft and terrain. Therefore, the pilot must delay this climbing right turn until they have arrived at the missed approach point.
Many of the same techniques for precision approaches apply to both single and multi-engine aircraft. It is possible that the pilot of a multi-engine aircraft, such as the Piper Seminole, may encounter a single-engine emergency during an instrument approach procedure. Should the pilot experience an engine failure on a precision approach, the first reaction should be to fly the aircraft, maintain control, and establish at least VYSE indicated by a blue radial line on the airspeed indicator at 88 knots in the Seminole. If an actual engine failure does occur, the pilot must make the decision whether or not to proceed with troubleshooting checklists or to instead proceed immediately to the engine securing checklist. This determination will be based on many factors such as aircraft performance, position on the approach, and pilot workload. If an engine troubleshoot is attempted and the inoperative engine still cannot be restarted, the pilot must proceed to the engine securing checklist. After the engine is secured, the pilot should maintain a zero side slip and the approach should be flown in as normal a manner as possible, always maintaining an approach speed of at least 88 knots. On a precision approach, the main difference with one engine inoperative is that, due to drag and performance limitations, the pilot must wait to extend the landing gear until the final descent to landing has commenced. In this case, the final descent to land begins at interception of the glide slope on an ILS approach. At this point, the pilot can run the previously discussed tuple checklist and the gear can be brought down. The final approach course can then be maintained all the way until a visual descent to landing is assured, at which point the pilot can extend flaps as needed. Once again, due to possible performance limitations, a missed approach procedure on one engine may be impossible and should be avoided at all costs. For testing purposes, the instrument rating PTS requires that the pilot maintain airspeed plus or minus 10 knots, altitude plus or minus 100 feet, and heading plus or minus 10 degrees prior to beginning the final approach segment. Inside the final approach fix, the PTS requires that the pilot maintain within 3/4 scale needle deflection on the localizer and glide slope. To find a complete listing of standards for precision approaches, reference the instrument rating PTS. For further information on precision approaches and their execution, reference the Instrument Flying Handbook in Chapter 7, the Airman's Information Manual or AIM in Chapter 1, and the UND Warrior and Seminole Standardization Manuals in Chapter 4. Good luck with the rest of your instrument training, and as always, remember to have fun and fly safe.